Gentlemen, do you know what your vehicle does to the environment?
Screw the environment.
Yeah, mate, having a big car is all about having fun.
You guys could have just as much fun using biodiesel made from microalgae.
Micro what? You mean like that seaweed stuff?
Yeah, let me explain. Let's go for a drive.
Alright, mate.
Let's go.
Let's go.
Microalgae are living, microscopic organisms that can be prokaryotes or basic eukaryotes. Unlike macroalgae, which include things like seaweed, microalgae are typically made up of just one cell and have no roots, stems, or leaves. These organisms can be found in all ecosystems on Earth, but most commonly exist in aquatic ones. All species of microalgae are photosynthetic, meaning that they can obtain energy and carbon by absorbing light and carbon dioxide. However, generally, microalgae have a very diverse set of metabolic systems, meaning they can sustain themselves using other means, depending on their environment. There is estimated to be over 50,000 different species of microalgae, but since we're interested in biodiesel production, we only care about the handful that are single-celled, eukaryotic, have a high lipid or fat production rate, and grow in aqueous environments. One example is a type of green algae called chlorophyce. In good conditions, a colony of it can double in size in just 24 hours. These green algae also have a lipid content of over 50% of its biomass, which is what is used to make the biodiesel.
Well, that's all well and good. But why are we using biofuel when we've got normal fuel?
Ah, I'm glad you asked.
Well, there are three main reasons. Firstly, microalgae can be used to make very good quality diesel. Admittedly, in some engines, it does generate more nitrous oxide emissions, which can cause acid rain. However, more importantly, the long chains of carbon produced by microalgae contain no sulfur and also burn more completely than the diesel that's pumped out of the ground. This means that with microalgal biodiesel, your vehicle would perform better and produce less soot, as well as less carbon monoxide and sulfur dioxide emissions. The second reason is that 98% of humanity's greenhouse gas emissions are generated by the burning of coal, natural gas, and petroleum. Part of this problem could be solved by the use of microalgal biodiesel, as the beauty of it is that unlike fossil fuels, it is relatively greenhouse neutral. What I mean by this is that through photosynthesis, microalgae do not emit but absorb carbon dioxide from the atmosphere. Of course, most of this carbon dioxide is re-emitted when the biodiesel is consumed. However, if you were to use it instead of fossil fuels, which currently make up over 80% of the world's fuel consumption, your vehicle would no longer be contributing to climate change. My last reason is that unlike fossil fuels and other biofuels, the consumption of biodiesel made from microalgae is sustainable. Contrasting from microalgal biodiesel, fossil fuels are not renewable, and diminishing reserves will become increasingly difficult and costly to exploit. As a result, without alternative fuel sources, it is widely expected that vehicles such as yours will become significantly more expensive to operate. Microalgae are also more sustainable than other biofuel feedstocks, as it has a far superior growth rate and doesn't necessarily require arable land.
Where do you get this microalgae from? Do they grow it in fields like this?
Oh, not quite.
Before we can make biodiesel, we first have to grow the algae, which can be done using many different methods. Microalgae reproduce at a rapid rate, completing an entire growth cycle in just a few days. Microalgae have 5 main growth phases: a lag phase, an exponential growth phase, a linear growth phase, a stationary phase, and lastly, a decline or death phase. While these organisms can grow almost anywhere, there are 3 main requirements that must be met to maximize lipid production efficiency. Firstly, nutrients such as nitrogen, silicon, phosphorus, carbon, salts, and vitamins must be provided in optimal proportions. These inputs can be obtained from many different sources, including wastewater or industrial emissions. Secondly, environmental factors such as temperature, light intensity, oxygen, carbon dioxide, and acidity must be controlled to cater for the requirements that are specific to the species grown. Ideal environmental conditions can be maintained effectively using closed systems called phytobioreactors. However, it is often more cost effective to use open culture systems, such as ponds and purpose-built dams. The third requirement for intensive microalgae production is turbulence, or mixing. This is a crucial requirement as it facilitates the exchange of gases, most importantly oxygen and carbon dioxide, and homogenizes the cell distribution, light intensity, and temperature. It has been shown that varying these three crucial requirements can change the gene expression and hence lipid composition of the cultivated microalgae. For example, nitrogen deficiency and salt stress was shown to induce the formation of 18 and 20 length carbon chains in a species of microalgae called Botrechos bruni. As a result, these three requirements must not only be provided, but applied in optimal proportions, specifically to maximize the quality and quantity of lipids produced, not just the microalgae itself.
I'll tell you what, mate, that does sound alright. How the bloody hell are you supposed to get petrol out of these tiny little algae? Ah, a fantastic question.
Well, the main processes involved in transforming microalgae into biodiesel are harvesting, lipid extraction, and trans-esterification. Microalgae can be harvested from their aqueous growth medium through sedimentation, filtration, or centrifugation. All three methods are typically assisted using flocculation, where a flocculant binds to the microalgae, increasing their particle size and making them easier to harvest. After separation from the cultural medium, the lipids can be extracted by overcoming the cell membrane, the equivalent of our skin. Traditionally, this has been done non-mechanically through freezing, acid-base reactions, organic solvents such as hexane or 96% ethanol, or osmotic shock, where a change in solute concentration around the cell creates rapid water movement across the cell membrane and thus causes it to rupture. More significantly, however, techniques using microwaves and ultrasounds have been developed to rupture the cell membrane and release the lipids mechanically. The third main step in biofuel production is trans-esterification. This is a multi-step reaction where a small alcohol is reacted with the lipids from the microalgae. This is typically performed in the presence of an acid or base catalyst as it speeds up the reaction.
I've got to tell you, mate, you won me over. This algal biodiesel sounds bloody amazing. Tell me, how long till we see it in one of these fellas? Ah, it's a tricky one.
Well, despite all of the advantages and techniques that I just explained, microalgal biodiesel still has two significant limitations. Firstly, even with the high growth rate, significant quantities of water and infrastructure are required to grow and extract insignificant quantities of biodiesel. To investigate this, we grew a culture of microalgae in 2 litres of optimal growth medium. Admittedly, we were unable to obtain a species that was best suited to high lipid production, but even so, in 3 weeks, only 2 grams of microalgae was produced, and theoretically, less than 50% of this 2 grams could be converted into biodiesel. The second constraint is that the production of microalgal biodiesel currently involves a great deal of processing, which will always be an economic limitation for the production of low-cost commodities like diesel. So without significant research, development, and government subsidies, it appears that microalgal biodiesel may not be commercially viable on a global scale for quite some time. Despite this, the potential that this renewable fuel source has cannot be denied, and its practicality in global use is only going to increase.
Ooh. Well, mate, guess you were right. You can still drive a big rig, have fun, and still go green. Thanks a lot for that. You've really opened our eyes.
Thanks, champ. Go off to the bush with you.
No worries. Back to the bush, son.